So very good morning, students. Welcome to IIT NEET Foundation or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the participant branches along with your class 6th students for today's session. As you can see on the screen, and you are well aware, my subject is physics. We are in class 6th. Our ongoing chapter, pressure, which is the last top chapter of our material. Today we are entering into the session number 2. So we started this chapter on Tuesday, and today we are entering the second session. So we'll continue where we left in the last class. But before that, let us recall what we learned so far. So before going for pressure, we learn about what is force, what is thrust, then of course area, and finally what is pressure. And with various examples we have seen in the videos. So as all you know, force is nothing but either push or pull. Either push or pull an object is called force. Either it may change the position of the object or try to change. Whereas thrust is nothing but perpendicular force. A force applying perpendicular to the body is called thrust. It is also nothing but force only. But when you want to open the door, how you apply force? Like this. We will push the door like this. Which perpendicularly you are applying force to open the door. Or wherever you want to do the rotating. So to produce the turning effects also, we apply the force perpendicular. When you are hitting the nail into the wall also, we apply the perpendicular force. So force can be applied many ways, but the force applies perpendicular is called thrust. Of course, you know the area already, the space occupied is also mathematical called as length into breadth. Then finally, we discuss about the pressure. Pressure is nothing but thrust by area or force by area, whatever it may be, same. Thrust per unit area is called pressure. Very important. Pressure, generally the word pressure is very familiar with us. We are using everywhere, not only in physics. In regular life also, we'll see, I am feeling a lot of pressure. Whenever there is more work, where more homework or more pressure by the examinations, we'll use this word. But as per physics, it is defined as the thrust per unit area or force per unit area. So it clearly explains us the pressure is directly proportional to force only. Greater the force, greater the pressure. Similarly, pressure is inversely proportional to area. Greater the area, lesser the pressure. Lesser the area, greater the pressure. Lesser the area, see, when you are hitting the nail, will hit a sharp end towards the wall, because sharp end will have less area when compared to the head. Right? So for example, you see, if we nail is like this is a small area, this is a large area. So we are hitting here, so that the small area, more pressure is exerted and insert the wall. We cannot hit insert the nail reverse order, as we have seen in yesterday video, right? So that is the logic here, because the pressure depends mainly on thrust and area of cross section, or area where we are exerting the pressure, that force, right? So these are the topics these are the points what we discussed in the form of maybe 5-6 synopsis also you wrote. Today we'll continue there only. We'll see what are the applications of pressure, So because till now what we are seeing is only the pressure on the solids, between the two solids. How the pressure exerted between two solids. When you, for example of nail also, that only. So many examples which are related to solids. So just we have some more thing for that. What are the applications of pressure? Then we move to the liquids and gases, right? So these are the things we are seeing already. What is thrust? What is pressure? Clearly given here. Synopsis 1, if you see, when a body is placed on a surface, the weight of the body acts in downward direction. Force exerted a body on surface is equal to weight of the body. The total force exerted by body perpendicular to the surface is known as thrust. Perpendicular. Force perpendicular. So units you can see here. As a force is a, thrust is also a measured in Newton only. Okay, Newton. In CGS dyne, MKS Newton or SI. Then we are seeing what is the pressure. Pressure is nothing but thrust per unit area. So mathematically, pressure is equal to thrust by area. Okay. So when you move further to the next slide, you can see here. Same extension, P is equal to F by A formula. So pressure is directly proportional to force and inversely proportional to area. And what is the unit of pressure? Newton per meter square. Because force is measured in Newton, area meter square. In CGS system, dyne per centimeter square. Or even it is named as Pascal also, named after the scientist. Pressure also can be measured in Pascal. So there is some relation also given here. What is on Pascal is equal to, okay, that is 1 bar is equal to 10 power 5 pascals. Bar also another important unit of pressure. Right? Now we have the applications. Applications of pressure. Where pressure can be useful in our day-to-day life. Application means nothing but how it is helpful for us in our regular life, day-to-day life. Okay. Hope you are well aware this word and you can see same. See here. Animal like camel walk easily on in deserts as compared to the horse or donkey because they have broad feet. You might have seen the animal, camel with broad feet, just like our skating board. Broad feet exert less pressure because area is more. Area is more, less pressure. Less pressure on the sandy ground because they have a heavy truck. That is the first example. Right? First example is camel. Camel can walk on desert very easily, sandy floor. Why? Because it has a wide legs. Right? Whereas it is not possible with the horse or donkey or dog or cat because they have small area. Area is small, pressure is more. When pressure is more, they'll insert into the sand. But because of this camel, area occupied is more for the legs, it can easily travel. Second one, a heavy truck is fitted with the 6 or 8 wheels. This increases the area of contact on their weight, acts as, and hence reduces their pressure on the ground. So we can see 2-wheelers, 4-wheelers, 6-wheelers, 8-wheelers, heavy trucks which carry the containers, big containers, right? So what they have more number of tires means more area of contact. As the more area of contact to the ground by the truck, the pressure is less, it will move easily. Right? To understand the logic, the wonderful example you can see everywhere. So whenever more area is occupied by the containers with more number of wheels, what happens? It can be reduce the pressure. When pressure reduces, area increases, automatically pressure reduces. Right? Clear, na? So that is a very important second example. You can see third one also. Very interesting again. Skater, I told already. Third one. The skiers use flat and long skis to slide on the snow. Sliders, you know, skiers. You can see in the movies, or you might have enjoyed your holidays during, you might have visited the cold places like Jammu, Kashmir, Makudu, Manali, where you can have the skiing that is called. Snow, because the larger the area of cross section, the less the pressure on the snow. So you can slide easily. How can you slide easily? Because of the skiers, which are very wide. Okay. Is for same reason, the sledges are never provided with the wheels because of the heels. Wheels increases pressure on the snow. Okay, they won't provide the wheels there. Wheels, what happened? The less area, so they won't provide this one. Okay. So cutting edge of the knives, blades, and axes are sharpened. Why you are sharpening? To reduce the area. When reduce the area, then automatically easily you can cut. We also seen yesterday in video. As the cutting edges are sharpened, the area of contact decreases, hence pressure exerted by that is increases. Thus, they are easily penetrate in a given surface. So, why you are sharpening the knife? To cut the vegetables easily or anything easily. So, while sharpening, what happened? The area of contact decreases. Area of contact decreases, pressure increases. So that easily you can cut. Thus, they can easily okay. So, under condition of high-rise buildings are kept wide, so that they are exerted less pressure on the ground and do not sink into the due to extreme high pressure. When you construct the buildings, high buildings, we cannot construct narrowly. It is very dangerous. Buildings, area of contact ground level should be more. Then only it can withstand the pressure. Right. So see how many examples are there. All these you can note in your notebooks. Just go through the material, and today's homework is you make this synopsis continuation for yesterday. So now it is not possible, but from material you can see the applications here. So many applications are there where you can understand the examples of pressure or applications of pressure in our day-to-day life. Right. Day-to-day life, what are the examples you can see here? Okay. So before going for next, let me show you one video on the applications of the pressure. After seeing that video, you can come back and we can continue with the next part. Okay. Just keep watching the video on applications of the
What is force? What happens when a force is applied to an object? While pushing, pulling, lifting, or hitting anything, we are actually changing the motion of an object. This change in motion requires force. So we can say that a push or a pull on an object resulting in its motion is called a force. Objectives. At the end of this lesson, you'll be able to define force, list the properties of force, understand the effects of force, distinguish contact and non-contact forces, list types of contact and non-contact forces, list properties of pressure exerted by solids, liquids and gases, list the effects of pressure on human activities, define atmospheric pressure. What happens when force interact? If you choose a heavy box and try to push it, the box will not move. Now if you ask a friend to help in pushing it in the same direction, it moves. This experiment proves that the forces are acting in the same direction and up.
You can see.
Effects of force. Consider a thin rubber balloon and blow air into it, the shape changes. Then tie its open end with a thread. Now press the air-filled balloon. You will see again the shape changes. This is due to effect of force. When you play football, the football is kept in the center of the field. When you kick it, it moves towards the given direction. Similarly, in the kitchen, your mother makes balls from dough and rolls them into chapatis. In this case, she is applying force to make them flat. Effects of force. One can change the direction of the object by applying suitable force on it. For example, in cricket, the speed of the ball hit by a batsman reduces to 0 when the fielder catches it. Also, if you kick a moving football, the speed of the football increases. Kinds of force. There are two major types of forces: contact forces and non-contact forces. Examples of contact forces are muscular force, force of friction, etc. Similarly, example of non-contact forces are magnetic force, gravitational force, etc. Contact forces. Can you push or lift a book lying on the table without touching it? Or can you lift a bucket of water without holding it? In both the cases, the answer is no. Generally, to apply a force on an object, our body needs to be in contact with the object. So we can say that contact forces are the forces which act on bodies when they are in actual contact. Basically, these are of two types: muscular force and force of friction. Muscular force. When we push an object such as a box or lift a bucket of water, then the force is caused by the action of muscles in our body. This force is known as muscular force. Note that muscular force is always applied either directly through touch or indirectly with the help of a stick or piece of rope. For examples, cutting the vegetable or fruits with the help of knife, hammering of nail with the help of hammer, pulling a cart by horse. Force of friction. Do you know why a heavy box on pushing does not move? Why a rolling ball stops after some time? When an object moves in contact with another object, a force known as friction comes into play. Note that the force of friction always acts on all objects and its direction is always opposite to the direction of motion. The moving object in the animation gradually slows down and ultimately stops due to the force of friction. This shows that force of friction always opposes the motion of one body over another body in contact. Types of non-contact forces. The types of non-contact forces are gravitational force, magnetic force, and electrostatic force. Do you know why the leaves or fruits fall to the ground when they're detached from the plant? This is because of gravitational force. The force due to Earth's attraction is called the gravitational force. This is an example of non-contact force. Now, the force between two magnetic poles placed at a suitable distance is called the magnetic force, in which like poles repel, while the unlike poles attract each other. A magnet can exert a force on another magnet without being in contact with it. So, the force exerted by a magnet is also an example of non-contact force. Do you know, when we rub a tube through dry cloth and bring it near the thread is attracted towards the tube. This is because on rubbing the tube through the dry cloth, an electrical charge is generated on the tube. This is called the electrostatic charge. This is also an example of non-contact force. Pressure. Let us perform an activity. Take 5 wooden boxes of almost the same size. Fill them with scrap iron to make them heavy. Arrange these boxes on a wooden table, placing them side by side. See the impact of the push force from these boxes on the table. You will notice that the table remains normal and it is not affected by the push force, that is, weight of boxes upon it. Now, rearrange these boxes on the same table, placing them towards the center and one over the other. Now see the impact. In this arrangement, the table either bends or breaks under the weight of boxes. Can you guess why does this happen? Though the force applied in both the cases is same, but in the first case, impact is less, and in the second, the table bends. This activity proves that both the force and its coverage area are important. The smaller the area on which the force acts, greater is the impact, and this phenomenon is known as pressure. We can also say that pressure is related to the force. Daily life example of pressure.
Yeah, now you see.
Have you ever noticed that why school bags have white straps? Why sharp knife cuts better as compared to blunt knife?
Area.
And why the tip of the needle is sharp? In our everyday life, we all experience the impact of pressure. A school bag has white straps so that the weight of the bag may fall over a large area of the shoulders of the child, thus resulting in less pressure on the shoulders. And due to less pressure, it is quite comfortable to carry the heavy school bag. A sharp knife has a very thin edge. It cuts objects better because the area of contact is very small. The force of our hand falls over a very small area of the object, producing a large amount of pressure. And this large amount of pressure cuts the object easily. Due to its sharp tip, the needle will put the force on a very small area of the cloth, producing a large pressure sufficient to pierce the cloth being stitched. Do liquid and gases also exert pressure like solids? Do you know what happens
Now we
when you
discuss.
blow air
Stop.
into a balloon? It exerts pressure in all directions. That's why the balloon increases in size and shows equal enlargement in all directions. The same is also true for the liquid. It also exerts equal pressure in all directions. When a plastic disc is submerged in water, it does not fall down. It is continuously pressed against the glass pipe by the pressure of the water. This implies that the water exerts pressure in all directions. Air and our atmosphere. We know that there is air all around us. This envelope of air around the earth is known as atmosphere. Actually, air has weight and therefore exerts pressure. The pressure of the air upon the surface of the earth is called atmospheric pressure. Note that atmospheric pressure decreases as we go up and up. On an average, the weight of air on our head is 1 kilogram per centimeter square. Daily life experience of atmospheric pressure. In our day-to-day activities, we experience various instances of atmospheric pressure. Some common examples are sipping cold drink through a straw, dipping the nozzle of the syringe in the liquid, or filling of ink in fountain pens. Do you know what happens when you sip the cold drink? The air pressure inside the straw is reduced, and the air pressure on the surface of the drink pushes the drink up into the straw to reach our mouth. In case of a syringe, the doctor dips its nozzle into the liquid and pulls the piston, thereby lowering the air pressure inside the syringe. Another example of ink-filled fountain pens that have rubber tubing, the rubber tube is pressed to push out the air from it, thus reducing air pressure inside the tube.
Examples are given. Some questions there is no need for us questions. Okay. So this is completely about the what is pressure and what are the applications of pressure, right? So next, after knowing about the pressure completely and their applications in our day-to-day life, so we have to move to the next part. So next part, that is we are in synopsis 2, we are going to discuss about the pressure of the fluids. Pressure of or pressure in fluid. So what is fluid? Fluid is nothing but matter which flows. Matter which flows is called fluid. Today's synopsis can write down. Put the date and write synopsis. So matter which flows is called, for example, you keep your notebook somewhere on the table. Will it flow? No, because in that all the molecules are tightly packed. So solids does not flow. Whereas if you drop some liquid somewhere, water, definitely it will flow slowly as per the place. So liquid flow and gases flow. So both liquid and gases together called both liquid and gases. Liquid and gases together called fluids. Very important point. Now we'll have to see, till now what pressure we discussed is about the solids only. When perpendicular force acts on a body, pressure acts on body. But what is type of pressure exert on the fluids? That is called fluid pressure or pressure in fluids. You notice these 2 points. And come here, clearly they are explained here. Where substance which can flow from one point to another is called fluid. Since liquids and gases can flow, so they are together, they are known as fluids. A liquid exerts 3 types of pressures. First, we are discussing about downward pressure, upward pressure, lateral pressure. Lateral means along the surface. Because of lateral pressure only, the boat will flow on a water. Downward pressure also, when you drop any body into the water, how the body will go inside first? Because of the downward pressure exerted by the liquid. Again, it will come back. Suppose you take one ball, cork ball or rubber ball, you drop it in the liquid, it will go up to certain height, immediately it will come back. Why? Because of the upward pressure. So means all the fluids, even just now you have seen the balloon. When you are blowing air into the balloon, because of the pressure exerted by air, balloon is bulging. Correct or not? That is pressure of the air. But when you see liquid here, you can see downward pressure, lateral pressure. For example, fill the balloon with water. First, make one hole at the bottom, will come. Sides shape, make so many holes. So pressure, because of the sideward pressure or lateral pressure, water will come out from the all the holes with great pressure. So these are the 3 types of pressures possible with liquids. See here, examples given. Consider a vessel containing some water of weight W, say 500 ml. Weight. Let the area of its base is A, 100 centimeters square. Then the weight of the water is the thrust acting on the base of the area 100 square meter. So see here. So liquid you are filled here, the pressure acts in the downward direction towards the base. Similarly, side you can see here. When you open, you make some hole in the side, the water will come with the falls with a great distance. Not they won't fall there only. It will come with the pressure. The pressure indicates that depends on pressure, the liquid will go and fall in some distance. Here's the third one. Take a football and immerse in the water. With pressure, we are immersed. When you leave that, what happened? Will come back. That indicates the upward pressure. That is called up thrust. That is also called buoyancy. We'll come across later. Force of buoyancy. First, what we are doing, we are pressing the football into the water. We hold hand. When you release the hand, it will come back. Why it is coming back? Because liquid is exerting the up thrust, upward pressure. Like that, liquid, or as we are discussing about liquid only, to exert 3 kinds of pressures. Downward pressure, upward pressure, lateral pressure. Means along the surface. It's also called as sideward pressure. Clear? So just about this also, I'll show one more video before closing the session on these 3 pressures. Of course, there's a lot to discuss about this. We'll continue in the next class. But before that, let me show you one video on a small video on pressure of the fluids.
Have you ever wondered why a large ship floats but a small pebble sinks? In this video, we'll learn about floating, sinking, pressure, and density. Density is a measure of how heavy something is relative to its size. It can be calculated using this equation. Try calculating the density of a wax candle that has a volume of 2 centimeters cubed and a mass of 1.9 grams. Pause the video to work it out. We can use density to predict whether an object will float or sink when it's placed in a liquid. If the object is more dense than the liquid, it will sink. If the object is less dense than the liquid, it will float. Water has a density of 1 gram per cubic centimeter. Will the wax candle with a density of 0.95 grams per centimeters cube float or sink in water? That's right, the density of the candle is less than the density of water, so it will float. Lead has a density of 11.3 grams per cubic centimeter, and liquid mercury has a density of 13.5 grams per cubic centimeter. What would happen if a block of lead were placed in a beaker of liquid mercury? Pause the video while you think. The lead would float in the liquid mercury. So that's a fairly easy way of explaining why solid blocks float or sink. There is another thing to consider: buoyancy force. All liquids are made up of particles that can slide over each other. When the particles collide, pressure is produced. The pressure in a liquid varies with depth and density and gravitational field strength. In a column of liquid, the water will pour out through the holes in the side of the container. The water that pours out of the hole at the bottom of the container travels further than the water that pours out of the hole at the top. This is because the water at the bottom of the container is under greater pressure than the water at the top. The mass of the particles pushing down on the water at the bottom of the container creates more pressure. The deeper the liquid, the greater the pressure. We can use these facts to derive the formula, where P equals pressure, ρ equals density, H equals depth, and G equals gravitational force. Imagine a cuboid submerged in a tank of liquid. The distance from the surface of the liquid to the bottom of the surface of the box is greater than the distance from the surface of the liquid to the top of the surface of the box. So H2 is bigger than H1. Because P equals ρgh, the pressure on the bottom surface due to the liquid must be greater than the pressure on the top surface. This results in there being more force on the bottom surface of the box than there is on the top surface. The difference between these two forces cause there to be a net force
So
upwards
clearly
called
indicates
the
that there is
buoyancy.
a force exert upwards, downwards, as well as lateral. Pressure will come in the many directions. Many directions pressure exerted by liquid. So that is the very important upward pressure, which is very important to come across. So many uses of upward pressure in our day-to-day life. So what we discussed today? Today we discussed about the very important applications of pressure in our day-to-day life and introduced about the fluid pressure, right? We introduced about what is the pressure of fluids, especially we discussed about pressure of liquids. Liquids exert three kinds of pressures. So this is with this we have almost completed synopsis 1 and we started the synopsis 2 and we'll continue in the next class. Just meantime, you can practice the more multiple choice questions of level 1 from these particular topics what we covered. You write in the notebook and show it to your teacher. Level 1 practice questions will be there. You practice them and put the signature from teachers and parents, right? That is your task for the day. Level 1 MCQs from material related to synopsis 1 and synopsis 2. Right. So that's all for today. Thank you very much, students. Have a wonderful day. Thank you.